So here we have the differential equation, and we need to solve by using the method of variable separation. So we'll have to make an assumption that x plus y is equals to some variable v, and then differentiate both sides with respect to x. That gives us 1 plus dy over dx equals to dv over dx. Isolating dy over dx, so we have dv over dx minus 1. Now our differential equations become, so we have dy over dx on the left hand side, so that will be replaced with dv over dx minus 1. That's equals to cosine of x plus 1, so that will be v plus sine of v. So furthermore, when we simplify this, we have dv over dx equals to 1 plus cosine of v plus sine of v. Now we can separate the differential, so we have dv equals to 1 plus cosine of v plus sine of v times dx, or simply put, dx is equals to dv over 1 plus cosine of v plus sine of v. So here we can see that the coefficient of a differential dv is purely a function of v, and coefficient of dx is 1, which is a function of 1. So that means we have a differential equation in the variable separable form. That means now we can integrate both sides. So let's perform the integration. So we need to perform the integration. Dx equals to integration dv divided by 1 plus cosine v plus sine v. So let's start with the denominator. So we have 1 plus cosine v plus sine v. So here we are going to use an identity. So let me note down the identity. So here we have cosine of v and sine of v expressed in terms of tangent of v over 2. So that means we have 1 plus 1 minus tangent squared v over 2 divided by 1 plus tangent squared v over 2 plus sine v. So sine v will be 2 times tangent of v over 2 whole divided by 1 plus tangent squared v over 2. So let's take these common multiple of all the terms in the denominator. So we have 1 plus tangent squared v over 2. So the first term in the numerator will be 1 plus tangent squared v over 2 plus 1 minus tangent squared v over 2 plus 2 times tangent of v over 2. So here we can see that tangent squared v over 2 gets cancelled out in the numerator. That leaves us with 2 plus 2 times tangent of v over 2 in the numerator divided by, so we have 1 plus tangent squared of v over 2, so that is an identity, but that will be secant squared v over 2. So this is the value of 1 plus cosine v plus sine v. Now we'll take the reciprocal, so that will be 1 divided by 1 plus cosine v plus sine v. So this is equals to secant squared v over 2 whole divided by 2 plus 2 times tangent of v over 2. Let's integrate both sides with respect to v. So we have integration dv here. Now this integral on the right hand side, so that can be solved by using the method of substitution. So let us suppose that let 2 plus 2 times tangent of v over 2, let this be equal to some variable t. Differentiating both sides with respect to v should give us, so we have secant squared v over 2 dv, so that will be equals to dt. So that means our integral now becomes dt divided by d, and that's simply natural log of t plus some constant of integration c. Let's call it c prime. Log of, so t will be replaced with 2 plus 2 times tangent of v over 2 plus c prime. And if we use the property of logarithm, so this can be written as log of 1 plus tangent of v over 2 plus c, where c is equals to c prime plus log of 2, and this is what was equals to integration of dx. So we have x is equals to natural log of 1 plus tangent of v, so v here is x plus y divided by 2, so plus c, and this is the required solution to a given differential equation. Thank you.